Hello everyone, welcome to the next session of chemistry chapter atomic structure, structure of atom. So in the last lecture we studied about the you can say the fundamental particle of matter, which is atom, which is also the smallest particle of any element. Also, we studied about how John Dalton gave some theory regarding atom, but most of the points suggested by him in his theory were incorrect as found in the early 20th century. Okay, after that, we studied about the discovery of subatomic particles, that is, electrons. We started with the cathode ray tube experiment. We studied how electrons were discovered. We studied what was the properties of electrons, and in the same way how protons were discovered. And after the discovery of proton, J.J. Thomson suggested a plum pudding model of the atom. Correct? So I told you that this, if you don't understand what is a plum pudding, you must have seen a half cut watermelon. How does it look like? It has the red color fruit pulp in which the dark brown color seeds are scattered or embedded. And in the similar manner, the red color pulp represents the positive charge of the atom, and the embedded seeds represents the electrons which are scattered. So that was the suggestion given by J.J. Thomson. But soon after J.J. Thomson's proposal of plum pudding model of an atom, another scientist in 1911, another scientist named Ernest Rutherford, or Lord Rutherford now he is known as, in 1911. He was a scientist from New Zealand, and he did one alpha particle scattering experiment in which he directed a stream of alpha particles. Now, what is an alpha particle? So, alpha particle is a doubly charged helium ion containing two protons and two neutrons only. It does not have any electrons. So, it is basically a helium nucleus. You know helium. How is the structure of helium? I'll show you the structure of helium. So it has this small nucleus, and it has one shell. So it has this small nucleus and one shell. So inside the nucleus there are two protons and two neutrons, and in the first shell there are two electrons. Okay, so we have two protons and two neutrons inside the nucleus, and two electrons revolving outside in the outermost shell. Now, this helium atom which you see over here, if from these two, if this helium atom, the two outermost electrons, if two electrons from the outermost shell are removed, so what will it become? It will become just the helium nucleus. It will remain just a nucleus. It will remain just a nucleus. So in the nucleus there will be two protons and two neutrons. That's it. And this is what you see here is known as a doubly charged helium ion, He2 plus. This is a helium ion. So helium ion consists of two protons and two neutrons. That is a helium ion. Okay, and this helium ion is known as an alpha particle. Alpha particle. Okay, it consists of two protons and two neutrons. It is formed by removing two electrons from helium atom. So now there should be no question in your mind that what is an alpha particle. Alpha particle is a nucleus of helium atom consisting of two protons and two neutrons. It has a positive charge of 2 plus. Okay, no negative charge because there is no electron. It is not neutral, it is positive. So Lord Rutherford, he directed a stream of alpha particles. Stream means there were many alpha particles. Thousands and thousands of alpha particles were there in that stream of alpha particles towards a very thin, how thin? 1 millionth of a centimeter thin gold foil. He directed this stream of alpha particle towards 1 millionth of a centimeter thin gold foil. He selected a gold foil because he wanted as thin a layer as possible, and gold is the most malleable metal. So he wanted to do one experiment which we will study in detail, but he wanted to do an experiment and see that what is atom made up of. If atom is made up of if atom, the structure of an atom is just like a just like how J.J. Thomson suggested, just like a plum pudding, or you can say a watermelon, how a watermelon is, then maybe the atom, let me draw a structure of atom just like a watermelon. If atom is like this, if atom if atom is this round, you can say positive charge, and there are these charges that are, those are negative charges, electrons scattered inside the atom. Then if I you can say uh, direct a beam of alpha particle, which is a doubly charged helium atom or a helium nucleus, towards this atom, they will not be able to penetrate this particular atom, because this particular atom is made up of full positive charges. Okay, so they will not allow these positively charged helium nucleus or alpha particles to enter. Moreover, these positively charged helium nuclei or alpha particles would just come near this atom and turn about, actually make an about turn, make a U-turn, and they will just repel back and go back. So does this actually happen? That's what was Rutherford curious about. So Rutherford did this experiment with a very thin gold foil whose thickness was 1 millionth of a centimeter. Just imagine, very thin gold foil. You can see the gold foil from the front side, but you cannot see it from the side view. The side view of gold foil will be so thin that it cannot be seen even with your eyes. So how did he make this gold foil? That's the question many students they ask. So since gold is very malleable, very you can say very highly precise roller machines were used to create such a small thickness of gold foil. Okay, so this kind of thin gold foil, which is thinner than the thinnest paper also, was created with the help of very high precision roller machines. Okay, the gold was rolled into this thin gold foil, which was used for this alpha particle scattering experiment. Okay, so what was the setup of this experiment? Here directly they have given the observations. Let me give you, the setup of this experiment. So here you see one diagram where the setup of the experiment is clearly uh, visible. So in this cube which you see over here, there is one source of alpha particle. Now this source of alpha particle can be any you can say radioactive substance. Remember, always remember that a radioactive substance, 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 a radioactive subst can emit alpha, beta, or gamma radiations. You will study this in higher classes. So alpha radiations are, I just told you, these are the helium nuclei, doubly charged helium atom consisting of 2 protons and 2 neutrons. Beta radiations are electrons and gamma radiations are neutrons. Okay, so a radioactive substance can emit alpha, beta, or gamma radiations. So Rutherford selected such a radioactive substance. Rutherford selected such a radioactive substance which can emit only alpha emissions. Okay, some books they also suggest that Rutherford constructed, or he procured an alpha particle gun. So alpha particle gun has a radioactive substance inside it, and when that gun is triggered, it's not like a normal gun or yeah Diwali ka pataka gun. It's not like that. Okay, when the gun is triggered, it emits these radiations which has alpha particles inside them. Now you know what are alpha particles. Okay, so we are interested in a radioactive substance which can emit alpha particles. So somehow this gun was made, this source of alpha particle was created, and through this source of alpha particles a ray or a stream of alpha particles was you can say directed towards a thin gold foil. Can you see the thin gold foil? Very thin gold foil. It was kept like this vertically, and the whole setup where the beam of alpha particle was entering a cave-like structure, a circular cave-like structure, and this circular cave is made up of a fluorescent material. In the last lecture, I told you about some fluorescent materials. One was soda glass, which we saw, and the other fluorescent material which we discussed in the last class was zinc sulfide. So he placed a screen, or you can say a cave-like circular structure surrounding the lateral area, lateral surface area, right? So surrounding the lateral area of this particular gold foil. So you can imagine that there is this round, and you can see it in front of you in the picture. There is this round screen which is surrounding the gold foil from all the direction, except it has a one very small gap here where the gap is only minimum, where the rays, the alpha particle rays are allowed to enter in. Other all the sides are closed, and it has a proper height and everything. So none of the alpha particles can escape this particular screen. Okay, so this was the setup. This was the setup. There was a gold foil. Surrounding the gold foil, there was a circular fluorescent screen and a source of alpha particle which can emit alpha particle at a very high speed. Okay, alpha particle gun or whatever you want to call it. Okay, so there is one more picture if you would like to see. See, one more picture. Right? So now it is absolutely clear that what was Rutherford's alpha particle scattering experiment. So what did he observe? It was observed. Now I would like you to look at another picture in which I'm going to show you what was observed in this alpha particle scattering experiment. So in this picture, there is a little bit of, you can say, zoomed in view. Just imagine that this is the thickness of your gold foil from here to here. So what we are doing is we are zooming in, and we are seeing that thinnest gold foil, whose thickness is millionth of a centimeter. Millionth of a centimeter thick gold foil is viewed as this particular thickness. Okay, of millionth of a centimeter thick gold foil when zoomed in can be imagined to be like this. And just uh, imagine that the gold foil is so thin that even if you zoom in and view it as this much thick, It has how many gold atoms lined up side by side? It has 1, 2, 3, and 4. Maybe 4 or 5 gold atoms lined side by side. Now, atom is so small. Just imagine, atom is so small. Then the atoms which are placed side by side a gold each other in a gold foil are only 4 or 5. So just imagine how small this thickness would be. Very small, very small thickness. Okay, so we are just zooming into this small thickness and viewing it in a side view, so what is happening? Most of the alpha particles are not deflected. Most of the alpha particles, they pass through the gold foil. Do you see that? Most of the alpha particles, they pass through the gold foil, as if there were no gold foil. Most of the alpha particle are passing through the gold foil, as you can see in all the pictures, as if there were no gold foil. Right? Now, I told you before this that if J.J. Thomson was right, and if J.J. Thomson's assumption regarding the structure of atom was correct, then the gold foil should not allow a single alpha particle to pass through it, because it would have been made up of whole positive mass, like this red part over here. So it would not have allowed any particle to enter it and pass through it. But here the gold foil allowed, in the real experiment which Ernest Rutherford conducted, the gold foil allowed most of the alpha particle to get through it, just like if there were no gold foil. Okay. Next observation, please be very attentive over here, because these are like crucial observations on the basis of which we are going to find out how the atom is structured. Next observation was that a very small number of alpha particles are significantly deflected. So do you see these alpha particles? They come and they get deflected by an angle which is more than 180 degree, almost 360 degree. They just make a U-turn. But they were very small in number. Very few alpha particles got deflected by a significant angle. And a few alpha particles, third observations, a few alpha particles are slightly deflected. Only a little deflection was produced. Okay, so see, this is what actually he observed. But what he saw was, uh, since the alpha particles were continuously emitted on this gold foil, okay, and everything was in place, and this experiment was done for a considerable amount of time, you can say that Rutherford observed that there were these shining, you can say, dots, which were seen here on the screen, on the other side, from this side. Okay, so I'm just showing because I don't have the other side to be there. But yeah, there were these shining dots which were uh, appearing now and then on the front side of the screen. That means most of the alpha particles are crossing the gold foil, penetrating the gold foil, entering the gold foil, and getting emerged out from the other side, and striking the circular fluorescent screen placed on the other side of the gold foil. So every now and then there were these shining dots which were coming and going, like Diwali lights. Chung, 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 chung. Many shining dots were happening here and there. Okay. Once in a while, a few shining dots were produced on the, you can say, on the far sides, that is closer to 180-degree angle. Mostly the shining dots were in this area, that is like directly opposite to the direction of gold foil, or direction of alpha gun. But very few, some dot over here, some here, some here, some here, very few, you can say, uh, alpha particles were scattered and through a large angle, and they used to form the dots over here, shiny dots over here. Okay, and rarely, that is once in a while, some of the alpha particle, they got deflected by an angle which is greater than 180 degree, almost 360 degree, and produced a shiny dot over backside. Like they bounced back. They could not penetrate, and they bounced back. These alpha particles, they just bounced back, and they form these shining dots on the backside of the screen. The alpha particles are just striking the gold foil, and they are coming back, and they are striking this circular fluorescent screen here and there. You understand? So this is what happened with the alpha particle scattering experiment, which was done by Rutherford. Now, Rutherford, he understood the whole thing which was happening, and his mind went completely crazy. He thought that I have discovered something really amazing which nobody can even think of. So what Rutherford told was that since most of the alpha particles are getting through the gold foil, he said that atom as a whole is relatively empty. Atom तो खाली जगह होती है बस. Just imagine, that's what he said. Atom as a whole is relatively empty. Okay. In the center of every atom, there must be a small, impermeable, non-penetratable, impermeable mass which is concentrated in a very, very, very small volume, which has a huge density, but that is in the center and it is occupying very small area or volume, and that consists of positively charged particles that are protons. So the center of the nucleus was then given a name. Center of an atom was then given a name of nucleus. So as you see the red dots in each of the gold atoms, that is the nucleus. Nucleus is a very small part of the atom, but other than that, the whole atom is empty. It has electrons, but electrons have negligible mass. So electron cannot stop these alpha particles from entering. Electrons will allow the alpha particle to get through them. Electrons will just move away, right? Huge object is coming towards you or passes by you. You cannot stop that huge object to pass by you. Or even if you are in the, एक ट्रेन आ रही है तुम्हारे सामने, तुम उसको रोक पाओगे? ट्रेन तुम्हें उड़ा देगी. वैसे ट्रेन की तरह हाई मोमेंटम के साथ ये जब अल्फा पार्टिकल उसके ऊपर स्ट्राइक करते हैं गोल्ड के फॉइल के ऊपर, द इलेक्ट्रॉन्स कैन नॉट स्टॉप देम. द इलेक्ट्रॉन्स जस्ट गेट अवे, गेट साइड, एंड लेट द अल्फा पार्टिकल पास थ्रू देम. So since most of the space inside the atom is nothing but empty space, it easily allows the alpha particle to get through. So most of the alpha particle get through gold foil. That is the reason, because the atom as a whole is relatively empty. Atom तो कुछ नहीं है, खाली जगह है. ठीक है? In the center of atom, there is a very densely packed nucleus which has protons, the positively charged particle. And once a while, when an alpha particle passes close to this nucleus, it gets deflected by large angles. Like a particle, maybe over here, you see over this, once in a while, very few particles, they just get deflected with large angles, one over here, they penetrate, but since they are closer to nucleus, positive charges repel each other. Alpha particle is made up of a positive charge. Okay, it is made up of two protons, and in the gold nucleus also there are protons, precisely 79 protons. Gold, atomic number of gold is 79. I'll tell you what atomic number is, but for now I think we can say that the alpha particles which are positively charged, when they pass closer to the nucleus, they get deflected through very large obtuse angles. And very rarely, some of the alpha particles, they bounce back. Why? Because they have a head-on collision with the nucleus, and they cannot penetrate nucleus, because nucleus is where all the mass of the atom is located. So they cannot penetrate nucleus, so they just bounce back and they go in the opposite direction, and they make this about turn like these guys are making. U-turn, and they produce a fluorescence over here on the back side of the screen. So he said that, Rutherford said that this is the thing. Atom as a whole is relatively empty, unlike J.J. Thomson. So J.J. Thomson was really, he was really disturbed, and he felt really agitated that, how can this be possible? Because I said with so much of you can say authority that, yeah, this is the thing, because it was me under whose guidance electrons was discovered and this and that. Yeah, but he could not be right. So see, scientists also, they cannot be every time right. Scientists make mistake, and through the mistakes other experiments and other scientists come to the correct conclusion, and it is all in the benefits of humanity. It is all in the benefit of our progress. So scientists always are, allowed to make mistake, unlike students. That is very sad part, that we are expected not to make mistakes in our work, and that is, I think, a very wrong idea. Yes, because a student's job is, or student's scope of work is very trivial. It is just memorizing few things and all. It is not innovation. So when your education becomes innovative, then you will be allowed to make mistakes. Like when you are doing some research work, mistakes are bound to happen, right? But yeah, so in Rutherford's case, he found many mistakes from J.J. Thomson's case, J.J. Thomson's observations or assumptions, right? So later, Rutherford, let's come back to our topic. Lot of, you know, lot of things, lot of informations I've given you regarding Rutherford's alpha particle scattering experiment. Now, what happened? Later, Rutherford generalized these results of alpha particle scattering experiment and suggested a model of atom known as Rutherford's atomic model. See, now everything was clear to Rutherford. So Rutherford did not only discover the nucleus, he discovered nucleus, but not only that, he actually figured out how atom looked like. What is the structure of atom in the reality? Rutherford was the first person to say that to the maximum accuracy. Heavy metals, note that this is something different and something important. Heavy metals such as platinum will show the same observation with alpha particles as shown by the gold foil. So if you have a platinum foil in the place of gold foil, it will show the same observation, that most of the alpha particle will pass through the platinum foil. Some of them will be deflected by large angles, and very few of them will be bounced back. But if light nuclei like lithium is used, then fast moving alpha particles may even push the light nucleus aside and may not be deflected back. That's why heavy metals like platinum and gold were used by Rutherford for this experiment, so that he can accurately tell that how an atom looks like. So Rutherford's atomic model, these are the, you can say, the points of observations which Rutherford made with with some concrete proof, not like just like J.J. Thomson. He did not just say that, okay, no, this is the thing because I feel so. No, no, no. According to Rutherford, his model looked in a specific manner because he had proof from his experiment. So let's see what he suggested how the atom looks like. According to his model, Rutherford's model, the atom contains a large empty space which is known as extra nuclear space. This is why most of the alpha particles pass through the metal foil without deviating from their path. Atom contains a large empty space. That's what I told you first. Atom as a whole is relatively empty. Atom कुछ नहीं होती है, खाली जगह होती है, इसलिए अल्फा पार्टिकल उसके थ्रू पास हो जाता है. Second point, there is a positively charged mass at the center of atom, known as the nucleus, in which the entire mass of atom is concentrated. Therefore, the nucleus is the densest part of the atom. See, all the things I told you earlier. The electrically positive nature of nucleus is positively charged, is supported by the fact that the positively charged alpha particle approaching the nucleus gets deflected. Why the alpha particles, which were at a very few instances, they get deflected by large angles and they get even bounced back because of this positively charged nucleus? Because alpha particle has a positive nature, hence nucleus must also be positive to send the alpha particles back in the direction from which they came. This proved that the nucleus contains protons. The size of nucleus is very small compared to the size of atom. This is proved by the fact that most of the alpha particle pass straight through the gold foil. Only, only only a couple handful of particles out of thousands of alpha particle get deflected back in the direction from which they came, and very few alpha particles they get deflected through large angles. That means nucleus has to be very, very small. Now, comparison on the size of nucleus and of an atom. Let's compare the size. Just imagine that uh, okay, just imagine that your atom is a football ground, football stadium, maybe like this, oval in shape. Okay, maybe circular in shape, or maybe oval, whichever shape you want it to be. Okay, so if atom is a football ground, if atom, the whole atom, is considered to be the size of a football ground, then you know what will be the size of its nucleus? Have you seen that? Okay, suppose this is the mid line of a football. That's what you call, right? Then this is that. This is the penalty area, whatever you call it, the D, or I don't know. Okay, so just imagine, uh, what is this place where football is kept when at the beginning of the game? The football is kept at this place, right? This is where the football is kept. I made the football very, very large. Football is small, of course. Football is kept at that place. At the same place, if you put a small p, p, peas, a small p. Okay, the small, you can say, you know your p, right? That small p, p-e-a-p. Okay, okay, a small p, if you imagine to be at the center of the football ground, that small p represents nucleus, and the whole football field represents atom. So that is the ratio, nucleus. That is the ratio of the size of the football field and the nucleus. That is the ratio of their size. So this is how you can do the comparison between the size of football field and the size of nucleus. So that's why all the alpha particles they pass through easily. Only a few alpha particles which exactly come near the nucleus they get deflected through large angles. Otherwise they pass through very easily because atom as a whole is relatively empty. Okay. The electrons. He also suggested few things about electrons, although he did not know that how does this happen. So Rutherford also made a mistake of suggesting a few facts without experimental proof. But yes, Rutherford suggested regarding the electrons that the electrons revolve around the nucleus at large distances from each other and from nucleus in circular orbits found in empty space of the atom. So electrons revolve around the nucleus at large distances from each other and from the nucleus and in circular orbits. Imaginary paths, basically, shells or orbits. An atom as a whole is electrically neutral because total positive charge of nucleus is balanced by the total negative charge of the electrons. That is, the number of protons and electrons in an atom are equal. Absolutely correct. But he did not speak anything about the neutrons because he did not know that there were neutrons, and there are neutrons. Now we know some neutral particles in the nucleus, and we will talk about its discovery also. Sixth point suggested by Rutherford. Electrons revolve around the nucleus in closed circular paths, orbits. The force of attraction between negatively charged electrons and the positively charged nucleus is counterbalanced by the centrifugal force acquired by revolving electrons. So any body which is moving in a circular path will have a force of attraction towards the center, which is known as centrifugal force. Centrifugal, no, any body which is moving in a circular path will have a tendency to move away from the center, which is known as centrifugal force. So centrifugal force is directed away from the center, and force of attraction of the force of attraction of the electrons towards the nucleus, force of attraction of the electrons towards the nucleus is directed towards the center, and away from the center is the centrifugal force of the electrons which are revolving in the circular orbits, and these two forces balance each other, and that's why the atom is, you can say, stable. So let me show you with the structure so that you might understand in a better way. So let's imagine that this is one nucleus. Let me draw one more. Let me draw one more small circle which represents, oops, so we already got that. Okay, so just imagine that this is your nucleus, and all the electrons are revolving around this nucleus in this circular paths, imaginary circular paths. Correct? Okay, so these electrons, they have a force of attraction towards the nucleus. That is because electrons are negatively charged and nucleus is positively charged. So they are attracted towards the nucleus, and also because they are revolving at revolving in this shell at a very high speed. They also have a force, a tendency, maybe say, you can say, which is known as centrifugal force. So centrifugal force, you are going to study in class 10, is a tendency of a body, tendency of a force, tendency of a body to move away from the center of the circle while moving in a circular path. तुमने देखा होगा कि you know that small what you can say, what do you call that small wheel, मोस्टली सीन इन प्लेग्राउंड्स, जिसके ऊपर बच्चे बैठते हैं और फिर उसको गोल गोल घुमाते हैं. इट्स अ हॉरिजॉन्टल व्हील. आई डोंट नो व्हाट यू कॉल व्हाट व्हील. No, merry-go-round or something, I don't know, whatever. Yeah, so in that, whenever you are holding it and you're sitting on it or you're standing on it and it is revolved with a high speed, you have a tendency to fall out away from that center. That is just a tendency, okay? So that tendency is known as centrifugal force. Okay, so Rutherford suggested electrons which are revolving at a very high speed inside the orbit, they experience this centrifugal force which is balanced by the force of attraction which is experienced by these electrons towards the nucleus. And that's why they keep on revolving. They do not go out or do not fall inside towards the proton. They just keep on revolving in its uh, place. Yeah. that was the last, you can say, suggestion or assumption of Rutherford regarding the structure of atom. Now, Rutherford's model of atomic structure is similar to the structure of solar system. Just as in solar system, the sun is at the center having maximum mass and the planets revolve around it. Similarly, in an atom, the nucleus contains the main mass and the electrons revolve around it in orbits or shells. Right? So he compared the model of atomic structure to the solar system, where there is sun in solar system, in an atom there is nucleus. Where there are planets in the solar system, in an atom there are electrons which revolve around the nucleus. So that was a simple explanation, or you can say observations or suggestions made by Rutherford. Now, in Rutherford's atomic model, you can say there are some drawbacks, and as I can understand that he did not talk about neutrons, right? That was the first drawback. In his model of an atom, in the nucleus, there were only protons, no neutrons. He did not talk about it. He did not know about it, maybe. And the second drawback, which I could say, is with the stability of the atom, stability of the structure of atom. He suggested that, the electrons will keep on revolving around in the nucleus and the atom will be stable. So more information, or more, you can say, experimental proof were not given regarding the stability of atom. So these are the drawbacks of Rutherford's atomic model. Uh, let's read what textbook has to say regarding the drawback of Rutherford's atomic model. The comparison of electrons with planets in the solar system is the main drawback of Rutherford's atomic model. According to the classical laws of mechanics and electrodynamics, if an electrically charged particle is in motion, it will inevitably radiate energy. So, the laws of physics went against the suggestion given by Rutherford regarding the structure of an atom. The laws of physics tells us that the laws of classical physics, which apply on planets and their motion in a solar system, they cannot apply on atom or atomic particle or subatomic particles like electrons, because subatomic particles are very, very small. Their masses are negligible. Second thing, they are charged particles. So when charged particles have a huge velocity, they tend to radiate energy, they tend to give out energy. So if an electron which is moving around the nucleus continuously, it should radiate energy, it should lose energy. As a result, it should be gradually pulled towards the nucleus, because it will lose its power of moving at a certain distance from the nucleus. So it will slowly lose energy, and it will spiral, like this spiral is shown. It will spiral towards the nucleus inside, and it should fall inside. But that does not happen, right? That means, what does that mean? That everything around us which is made up of atom will collapse on its own. As soon as it is created, it will get collapsed, but we don't see things collapsing around us. So this, you can say, the reason behind this, why atom is not self-destructible, why electrons do not lose energy when they move at a high speed around a nucleus, why electrons do not fall into the nucleus, and why the total collapse of an atom does not take place. That was not explained to us by Rutherford. So that is the main drawback of Rutherford's model of an atom. So if it was so, the atom should be highly unstable, and hence matter would not exist in the form that we know. However, we know that an atom is structurally stable. Thus, Rutherford's model failed to explain the stability of atom. And then came, in 1913, Niels Bohr. Niels Bohr, a Danish physicist who was based in New York, America, USA, explained the causes of stability of atom in different manner. So let's study about Bohr's atomic model. What did Bohr tell? So main postulates of Bohr's atomic model. Are you able to understand the whole story? Are you able to follow हम लोग कहाँ से कहाँ जा रहे हैं? See, we started with the introduction that was some assumption made by uh, the philosopher, ancient philosophers, let's say around 2, 3, 4, 5,000 years back. From there, we came. See, everybody thought that there is a small particle of which this atom is made up of, which is indestructible. Then came in 19th century, early 19th century, John Dalton, who gave some theory regarding atomic structure. Main All the main postulates of this theory were not correct, but yeah, some of them were accurate. And then slowly the discovery started happening as the science and industrial revolution proceed. And then we understood what is an element, what is an atom, and what constitutes an atom. And for the first time, William Crook, he saw that cathode rays could be created, and then J.J. Thomson, went ahead and discovered electrons, and then there were cathode rays, and then there was anode rays, and protons were discovered, and then J.J. Thomson put forward a plum pudding model, and then Rutherford suggested them no, that model is absolutely wrong, and Rutherford suggested a model which was very much similar to the uh, you can say solar system, and he was very close to the truth, but still he could not explain the stability of model. And then came Niels Bohr in 1913, who explained stability of an atom. Now see, Niels Bohr actually agreed with Rutherford's model of an atom. He agreed with it. He didn't find any faults in it. He didn't say that no, it's completely wrong, I'll say everything all over again. No, he said that, see, Rutherford is correct. Atom has a nucleus in its center, okay, and it is very small in size, it is positive in nature, and everything is correct. But the stability of an atom, as explained by Rutherford, was not accurate. He didn't know, he did not have, or he did not give any idea regarding how electrons were located in those orbits. How many electrons were there, and all the details regarding the electrons was not given by Rutherford. So Bohr came in the picture, and he gave some very strong, you can say, proofs with the help of his research and experiments that this is how an atom is. Okay, uh, let alone the nucleus and the uh, shells around the nucleus in which electrons revolve, but how are these electrons distributed? He gave that answer. So the main postulates of Bohr's atomic model: the electrons revolving around the nucleus are confined to certain fixed orbits called shells or energy levels, each of which is associated with a fixed amount of energy. So Niels Bohr told that around nucleus there are some fixed shells which are associated with some fixed energy level. Each shell has a fixed amount of energy level. The electrons revolving around in a particular shell, let it be first shell or second shell or third shell or fourth or fifth or any shell around the nucleus, each shell would have a definite amount of energy associated with it, with which the electrons revolving in that shell uh, with which the electrons will revolve in that shell. So electrons revolving in that particular shell will possess that fixed amount of energy which is associated with that energy level or shell. So that was a very important, and you can say very path breaking and profound statement of truth which was given by Niels Bohr regarding an atom or atomic model. So electrons revolving around the nucleus are confined to certain fixed orbits called shells or energy levels, and each of which is associated with a fixed amount of energy. Okay. While an electron is revolving around the nucleus, in an orbit, an electron neither loses nor gains energy. Since each orbit is associated with a fixed amount of energy, electron is neither allowed to lose energy nor allowed to gain energy while revolving in that orbit. मतलब इलेक्ट्रॉन जब वो ऑर्बिट में रिवॉल्व होता रहेगा अराउंड द न्यूक्लियस, उस शेल में, उस पर्टिकुलर ऑर्बिट में, इलेक्ट्रॉन विल नीदर गेन एनर्जी nor lose energy. Third point, an electron revolving in a particular orbit, on gaining a certain amount of energy, jumps to the next orbit and vice versa. What do you mean by next orbit? ये जो next orbit है ना, इसका मतलब है outer orbit. मतलब कोई इलेक्ट्रॉन अगर सेकेंड ऑर्बिट में रिवॉल्व कर रहा है और वो इलेक्ट्रॉन अगर एनर्जी गेन करता है तो इट विल जंप इन द थर्ड ऑर्बिट, और एनर्जी गेन करता है तो इट विल जंप इन द फोर्थ ऑर्बिट, फिफ्थ ऑर्बिट, एनर्जी गेन करते करते इट विल जंप इन द सिक्स्थ ऑर्बिट एंड देन इट विल लीव द एटम and it will be donated, and that's what happens with metallic atoms. Okay, but इतने सारे ऑर्बिट्स जंप करने के लिए इलेक्ट्रॉन्स को जो सफिशिएंट एनर्जी मिलनी चाहिए वो बहुत रेयर केस में होता है, तो ऐसा नहीं होता. बट एक चीज पक्की है, वेन एवर an electron is revolving in a particular orbit, when it gains a certain amount of energy, it jumps to the outer orbit, next orbit, and vice versa. Vice versa matlab, whenever an electron is revolving in a particular orbit, if it loses energy, then it jumps to the inner orbit, which is nearer to the nucleus. ठीक है, तो इसका क्या मतलब है? इसका ये मतलब हम निकाल सकते हैं that the electrons which are revolving near the nucleus, to the nearest or the first or the second shell, you can say, which are nearest to the nucleus, have got the least amount of energy, and they will revolve with a slow speed. They will revolve around the nucleus with a slow speed. ठीक है, मतलब शेल वन पे, ऑर्बिट वन पे या शेल वन पे कोई इलेक्ट्रॉन अगर घूम रहा है तो उसकी एनर्जी मिनिमम होगी एज कंपेयर टू द अदर इलेक्ट्रॉन्स इन शेल 2 and 3 and so on. Also, it will be revolving with a slow speed. But as the electrons, as you go up higher in the shells, that is second shell, third shell, as you go away from the nucleus, as you move outwards from the nucleus, what will happen? The electrons in the outer orbits, fourth shell, fifth shell, they will have more energy and they will be revolving around the nucleus in that particular outer shell with greater speed. Okay, so this is what Bohr's atomic model, the postulates of Bohr's atomic model suggested. Okay, regarding the energy. See, Rutherford never dreamed about it. Okay, never thought about giving this kind of insight because the research of Rutherford was limited. But the research of Niels Bohr was more profound. It was more in depth. He had more, you can say, you will study in class 12th. There is a chapter called Atom and Nucleus, in which you will study that how Bohr gave certain mathematical proofs to the theories which were suggested like 50-60 years ago from his time. तो जो 19th सेंचुरी के मिड में जो थियरी दी थी किसी साइंटिस्ट ने, उसका मैथमेटिकल प्रूफ बोर ने दिया हुआ. ये तुम पढ़ोगे आगे 12th में, राइट? सो दिस काइंड ऑफ insight was given by Bohr, which was never denied. हाँ, इसके ऊपर और रिसर्च हुए and this was more, you can say, refined, but it was never denied because this was correct. Okay, so since each, I hope you are taking notes because I'm telling a lot of things which is on record. ये सब recorded है यार, ये बेस्ट चीज है, ये सब recorded है, क्योंकि इतनी इंफॉर्मेशन या इतनी स्टोरी या इतना कन्वर्सेशन किसी एक टॉपिक के बारे में हर साल में करता हूं, अब तक 10 साल से कर रहा हूं, बट अब मैं पहली बार इसको रिकॉर्ड करके तुम्हें दे रहा हूं. ये लो बेटा, जब देखना है तब देखो, भूल गए फिर से देखो. सो दिस काइंड ऑफ, यू कैन से, privilege is very rare, and we have found this privilege in the wake of this crisis called COVID or Corona, whatever it may be. But I think it should be a blessing for all of us. For me also, I feel it is a blessing Because when in future you want to revisit the whole topic, you can just look at this video and understand everything whatever I said. You understand? So even if it is for your exam, or you want to study for something higher, and you want to go through this, how the structure of atom was unfolded, and how it was found, and how the discoveries were made, we have everything on record, the whole conversation, the whole lecture, right? Let's go ahead. So since each orbit is associated with a fixed amount of energy, Bohr called it an energy level. This name was given by Bohr. For convenience, these energy levels are labeled K, L, M, N, or 1, 2, 3, 4. The orbit closest to the nucleus is the K shell. It has the least amount of energy, and the electrons present in it are called K electrons. And so on with the successive shells and their electrons. Simple. Okay, then comes the last atomic particle. See, now the structure of atom is ready. Now we know that there are electrons inside an atom. Now we know that there are protons inside the atom. Now we know how the how the structure of atom is, how there is a nucleus inside which the protons are there, but one particle is missing. Okay, now we also know that how the electrons revolve around the nucleus, in which manner, and we know everything about it. The last of the thing which is to be found is the discovery of protons, sorry, discovery of neutrons. So by now we know that atom contains electrons and protons, and the atomic mass of an electron is negligible. What is the mass of electron? Negligible. It is 1837, 1 upon 1837 times the mass of a proton. That means 1,000 times, 1,800 times, around 2,000 times less than the mass of a proton. That means it has, proton itself has a very less mass. So electron will be considered as a negligible mass. So an atom, let's say atom of a helium which contain two protons, should have a mass of 2 AMU. I told you in the last lecture what is AMU, atomic mass unit. But by experimental verifications and research, it was found that helium had a mass of approximately 4 AMU, 4 atomic mass unit, which was double the mass which it should have in ideal case. And that not only helium, but most of the atoms, they showed this anomaly. Anomaly means a defect. This was not a defect, this was a revelation. Carbon was thought to be having a mass of 6 atomic mass unit because it contained 6 protons. But when calculations were made, when research and experiments were conducted, carbon was found to have a mass of 12 AMU, 12 atomic mass unit, which was double its original mass, which it thought to have. So what was wrong? What was the problem? The problem was assumption. The assumption was made that since atom is electrically neutral, it could contain negative and positive particles only. But everybody forgot that since an atom is electrically neutral, it must have negative charge, negative particles. It must have positive particle, but it can also have neutral particles, because neutral particles do not contribute to any charge. Atom still will be neutral if we add some neutrons in it, and there are already neutrons, we don't have to add it. Yeah, but neutral particles might have some mass. So it was therefore proposed that in the nucleus of an atom there must be another particle. This particle should not possess any electrical charge and must be equal in mass to the mass of proton. And in 1932, just imagine, इलेक्ट्रॉन्स की डिस्कवरी हो गई, रदरफोर्ड का एक्सपेरिमेंट हो गया 1911 में, 1913 में बोर आ गया अपनी थियरी के साथ, मेन पॉस्टुलेट्स उसने दे दिए, एनर्जी लेवल्स तक की बात कर दी उसने, इतनी डीप डीप कैलकुलेशंस. बट आफ्टर दैट, you can say 20, around 20 years have passed, And then somebody called James Chadwick comes with the proposal that atom contains one more particle which we all are forgetting about. And that particle was neutron, electrically neutral but in mass, in equal in mass with the mass of proton. So in 1932, Chadwick discovered these particles by bombarding light nuclei like beryllium with alpha particles, that is helium nuclei. So when beryllium was bombarded with helium particle, helium alpha particle, you can say, it got converted into carbon. So atoms can get converted into some other particles with these kind of bombarding and fusion, you can say. So some kind of fusion was created. No, 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 no. Was this fusion? Yes, it was a fusion. And a neutron was emitted. These particles are found to be neutral. So the name was given to it was neutrons. सो अ न्यूट्रॉन, देखो ये वाला जो बॉम्बार्डमेंट का एक्सपेरिमेंट है चैडविक का, इसका कोई डिटेल्स नहीं दिया है, ना इसको पढ़ने की जरूरत है, बट एक याद रखना है इसको तुम्हें, ठीक है। देखो इफ यू आस्क मी कि सर आप क्यों नहीं पढ़ा रहे हो इसको डिटेल में, हमको जानना है कैसे पढ़ना है, लेट मी टेल यू, वी हैव अ लिमिटेड स्कोप ऑफ सिलेबस बिकॉज द चैप्टर इज ऑलरेडी ह्यूज। अभी तक हम लोग 50% चैप्टर भी हमने कवर नहीं किया। इन दिस केस इफ यू एक्सपेक्ट के हर एक एक्सपेरिमेंट के डिटेल में जाओ और उसके पीछे की स्टोरी बताओ, और फिर चैडविक, जेम्स चैडविक के कितने बच्चे थे और उसके फैमिली में क्या हो रहा था जब उसने ये सब मैं नहीं बता सकता स्टोरी, यू नो। इट इज लाइक गोइंग डीपर इनटू द एक्सपेरिमेंट, इट इज लाइक दैट, you know, when a movie is made on a certain event in the life of a scientist, they go into depth details, कैसे हुआ था ये discovery. If you see some real life non-fiction movies which are made in Hollywood, like amazing movies, you know, one of the movie which I currently I'm planning to see is Current War. And Current War is based on the war of current, of alternating current and direct current, ठीक है। And it has Benedict Cumberbatch in it in a very pivotal role of Nikola Tesla. You must have heard about Nikola Tesla. Tesla was basically a great scientist who made path-breaking discoveries in the world of physics. Great physicist on whose name this Elon Musk has founded a company, Tesla. Tesla motor vehicles, electric cars, basically, right? So that Nikola Tesla was the founder of alternating current. He found alternating current, and the company which was originally founded by the guy who discovered this electric bulb, which was who was that? Watson? No, not Watson. Watts, James Watts. No, 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 no. Who discovered electric bulb? Yeah, whoever it might be. So the his company and Nikola Tesla, they go into this kind of in opposite parties, and they, so that is a story which is shown in such a detail, and each and every event from that particular discovery was discussed, and this and that. So I cannot go into that detail, you know, because I'm not making a movie. Okay, so I'm just discussing, but I want to make it interesting for you. So in between, I can have a small talk with you, but it's difficult for me to go into detail about each and every experiment. But if you are really interested, I want you to search videos on YouTube, some articles on internet, and you will find all the details about these era, how the atomic structure was unfolded. Right? Let's stick to our syllabus for now. A neutron is a subatomic particle or fundamental particle of an atom with no charge and mass almost equal to the mass of proton, that is hydrogen atom. Neutron is denoted by N. In the superscript there is 1 and in the subscript there is 0. The superscript 1 represents the mass of neutron, which is a unit mass, that is 1 AMU. And 0, subscript 0, represents its electric charge. 0 charge means it is electrically neutral, it has no charge. What are the properties of neutrons? The particle was not found to be deflected by any magnetic or electric field, proving that it is electrically neutral. Its mass is equal to 1.676 into 10 raised to minus 24 gram, which is almost equal to the mass of proton. After the discovery of electrons, protons, and neutrons, subatomic particles, it was found that all the atoms have similar following basic structure. In all atoms, electrons are there, which are negatively charged particles that are found outside the nucleus. Protons are positively charged particles that are found in the nucleus of an atom. And neutrons are electrically neutral particles that are also found in the nucleus, and neutrons are slightly heavier than protons. So these were the common characteristics of all subatomic particles which are found in all different types of atoms. Then what makes atoms different from each other? It is the structure in which these atoms are situated inside any matter. In air, the atoms are far away from each other. In in metals, the atoms are tightly packed. That's why as a solid is different from a gas. Atoms are same, but how they are located, how they are situated, that makes the whole difference in how a matter looks like, right? So there is a comparison given between Dalton's atomic theory and modern atomic theory. I want you to I want you to pause the video and note down this comparison. They're very important. Most of all the points are discussed by us in great detail, but I want you to note it down. Since we are taking notes, we should take proper notes of whatever details are provided to us. So pause the video and note it down.